Now the topic is vibration and acceleration. Vibration and acceleration. The quantities required to measuring the vibration systems are 1. Displacement, velocity and acceleration. Before to enter to this topic, I mean vibration and acceleration, we have to know what is called displacement, velocity and acceleration. What is a displacement? Displacement means a person move from one point to other point. Suppose you are moving from Nellore to our college, Gudu. So this is a displacement. Its unit is meter. Next one is velocity. What is velocity? Velocity is also a vector that it is having a direction and rate of motion. Rate of motion. This one is a vector. I mean first one is a displacement. Displacement is a vector that is having only direction. Its unit is meter. That is one point to another point. So its unit is meter. Second one is velocity. It is also a vector that is having a direction and rate of motion. So therefore the unit is meter per second. And then last one is acceleration. What is acceleration? This is also a vector that is having a direction and magnitude of rate of magnitude in change of velocity. So its unit is meter per second square. This is the difference between acceleration, velocity and displacement. Displacement unit is meter, velocity unit is meter per second, acceleration is meter per second square. Okay. Then displacement, velocity and acceleration are related to each other. If one of the three variables, I mean displacement, velocity and acceleration is measured, it is possible to determine the other by integrating or differentiating using electronic circuit, by using a differentiator and also a integrator. Displacement, already we discussed LVDT, linear variable differential transformer, already discussed. Velocity, electromagnetic velocity measurement, already discussed in previous two topics. Now we can discuss about acceleration. Seismic acceleration. The diagram of seismic acceleration is shown here. The seismic accelerometer to measure acceleration is shown in figure. It consisting of mass M. This is the mass M. Damping D. This is a damper. And spring K. This one as shown in the figure. These three components are connected properly in a frame. This is the frame. These three are connected in a frame. The housing or frame is rigidly connected whose acceleration to be measured. This entire frame is connected to whose acceleration to be measured. The mass has a tendency to remain in spatial position. Mass means it's a weight without a gravitational force, that it is a mass, that it is tendency to spatial position. Then the vibration is registered through a displacement transducer. This is a displacement transducer. This displacement transducer occurring the relative displacement between the mass and housing frame. See, this displacement transducer is connected intermediate between a mass and this frame. This frame is connected to whose acceleration to be measured. So, if any vibration or any acceleration is happened to the frame, that it attack the mass, since the mass is not rigidly connected, that it is connected with a spring and damper. So if any force from the frame is given to seismic mass, that it get vibrate or accelerate. Okay. Therefore that will be sensed by that transducer which is between this mass and frame. Okay. Then the vibration is registered through the displacement transducer. The displacement transducer acquiring the relative displacement between the mass and housing frame. This displacement is sensed and indicated by a proper transducer, that is a displacement transducer. Two different modes of seismic transducer. One is a displacement mode, another one is acceleration mode. Displacement mode is meter, unit is meter. This one acceleration is meter per second square. Okay. Then the displacement mode or measurement is achieved by a selective large mass and soft spring. Displacement mode, we have to connect a large mass. For acceleration mode of measurement, selecting relatively the small mass. The mass must be a small for acceleration mode. The main difference between displacement, velocity and acceleration is unit measurement. Previously, when the starting of this topic, I told the phase difference between the amplitude and time curves of the three parameters. Displacement, unit is meter, okay, or millimeter. Velocity, meter per second. Acceleration, meter per second square. Vibration, displacement, velocity and acceleration are measured by seismic transducer. Vibration is, we can also measure displacement, velocity and acceleration. Okay. In seismic transducer, different type of displacement transducer are used to based upon the measurement or requirement application. Potential accelerometer uses the variable resistor which is used for low frequency application. Okay. LVDT accelerometer are used to steady state and low frequency vibration measurement. Piezoelectric accelerometer are used for high frequency vibration. So in this frame the transducer is replaced. If the transducer is a piezoelectric, that it is are used for high frequency vibration measurement. If this transducer is a LVDT, that it is used to measure a steady and low frequency vibration. If this transducer is a potentiometer type, uses a variable resistor which is used for low frequency application. That's all.